Okay, everyone, if you need help with the foundational worksheet, I'm going to go through these questions with you so you can fast forward to the ones you need and you can pause at any time. Okay, so let's take a quick look at number 1. First thing we're going to do is draw the line so we can separate. Okay, and we have to put family members together, so -4 on both sides. We do the opposite. So bring down negative 2x equals 6. And we divide by -2. X equals -3. Okay. Number 2. Same thing. We're going to draw the line. And this time we already have family members on the same side. So 2x and 5x go together and to make 7x. Okay. And we subtract the 7 over to the 21. So this is 7x equals -28. Divide by 7. X equals -4. Okay, let's take a look. Number 3, it's getting a little trickier. We have distributive property. So we're going to distribute. 3 times x is 3x. 3 times -4 is -12. We bring down 3x equals -12. Now, if you notice, these are on the same side and they're family. When I put them together, they cancel out. So I'm left with -12 equals -12. This means I have infinite solutions because I have balance on both sides. It's a tricky one. Okay, number 4. This is variables on both sides. So we have letters on both sides we've got to take care of. When I subtract 4x, same thing, this happens again. Both of my x's cancel out, but this time I'm left with -8 on the right and I'm left with +10 on the left, which are not the same thing. This is no solution because they're not balanced, so there's nothing that's going to work. Okay, that should be the help on page 1. Page 2, we're finding the rate of change of the table. I can tell that this one is going up by 3. And this one is going up by 2, so my rate of change is 3 over 2. Remember, your rate of change is y over x. Okay, the rate of change of the equation is right here. We can write 4, or it might even be more accurate to be 4 over 1. Okay, rate of change of the graph. We're going to start here on the left, and we're going to go down to over 3. Okay. So we're going down 2 over 3. So this is -2 over 3. Okay, number 4, the rate of change of the situation. So it's $100 for a printer, and the ink cartridge is $25 each. There's your key word. So y equals 25 each, plus the $100 we're going to spend no matter what. So my rate of change is 25. Okay, that takes care of page 3. Write an equation of the line with a slope of -3 and a y-intercept of 4. So this is slope of -3, which is m, and a y-intercept of 4, which is b. So y equals -3x plus 4. That's it. Equation of this graph. Well, here is my b right here. So b is -1. And if I count my slope, I'm going up 2 over 1, up 2 over 1, up 2 over 1. So that means m is 2 over 1. So it's y equals 2 over 1 x minus 1. Okay, moving on. What is the equation of the graph? Once again, y-intercept is at 3, so b equals 3. This is down 1 over 3, down 1 over 3. So m is -1 over 3 because we're going down. So y equals -1/3 x plus 3. Okay, equation of the table. This is going up by 4, and this is going up by 2. So this is y equals 4 over 2x, and then don't forget we look for the 0 plus 10. I can make this look prettier though because 4 divided by 2 is 2. So we should simplify if we can. Okay. Last 2 on this page. Write an equation of the situation. Sandy charges $2 an hour for babysitting. That's my rate of change. Parents are charged $5 if they arrive home later than schedule. So it's y equals $2 per hour plus the $5 if they're late. Okay, an equation for the table. I can tell that this table is going up by 4, and this side is going up by 1. So it's y equals 4 over 1x. Now, we're missing the 0 on the table, but if I continue on to get the 0, that means I'd have to go up 4 more on the right, which would give me 16. So this is plus 16. Compare the rates of change. Okay, so F, we're looking at F. This is F. And the rate of change, so the slope is 3. Let's find the rate of change of the table. The table is G. So this is going up by 1, and this is going up by 2. So this is 2 over 1. So comparing, F is greater. It's got a greater rate of change than G, because 3 is bigger than 2. Okay, let's try it again. Which car is going the fastest and how do we know? So when we look at all these cars, we have to figure out which one has the greatest rate of change. So car A is going up 1 and over 1, 2, 3, 4, 5, 6. A is 1 over 6. Okay, car B is going up 1 and over 2. So car B is 1 over 2. Okay, car C. Car C is the red line, and that's going up 2 over 2. That's 2 over 2, which is 1. And car D is going up 1, 2, 3 over 2. 3 over 2, which is 1.5. So D is traveling the fastest. How fast is B going? B is going 1/2, right? Which means in 1 mile, it moves 2 seconds. Which car is traveling the slowest? Well, the smallest fraction is A, so A is traveling the slowest. Okay, let's compare again. Comparing table to graph this time, but this time they want the y-intercept. So here's the y-intercept for F, it's -2. And the y-intercept for G is right here, smack dab in the middle, is 0. So if we're going to compare, the y-intercept, G is greater because G is 0 is bigger than -2. Page 5. An airplane's altitude is given by the function A equals -400x plus 1200, where A represents the altitude and x represents the time. Okay, so which airplane starts off at a higher level? So this airplane starts at 1200. That's where it begins. This airplane B starts at 3000. So airplane B starts off at a higher level. Which plane is descending at a greater rate? Well, this one is going down 400. And this one is going down 500 each time. See how it's 2,500, 2,000, 1,500? This one's going down by 500 every time. So B, again, is falling at a greater rate. Okay. John and Rebecca are in a savings club at their local bank. They start planning to open a savings account with $100, and he saves $25 a week. So John starts with $100, and he's saving $25 a week. Rebecca is starting with $0, so that's her initial. But Rebecca is saving $35 a week. This is going up by 35. So we can say that John starts with more, but Rebecca saves more each week because she has a greater rate of change. Okay, good luck.